In this video, we'll take an overview look at the Git version control system. We will begin with version control in general and then talk about Git specifically. We can think of version control from the perspectives of content, teams, and agility. Version control manages a collection of changing and improving files, which we can call a project. The complete history of the project is tracked and available at any time. Version control also supports teams working on that collection of files. Teams work in many different ways, and a good version control system will support many of their workflows or ways of getting work done. Version control helps support collaboration on the project and improves quality through facilitating team communication and reviews. Finally, version control enables agility, the ability to adapt quickly and constructively to a changing environment. It does this by managing small changes to a project and by allowing you to easily test, fix, or undo any ideas and changes that the team makes. What type of content can be managed with version control? Most version control systems don't really care. Any content that you value and want to continuously improve is a good candidate for version control. Git is commonly used for managing the source code related to software projects. Git is especially good at managing text-based content like this. Code that is used to run tests is also a good candidate for version control. The tests need to be properly managed and are usually always improving. Version control is not limited to developer-related projects. IT teams should manage configuration information in version control as well, so that the infrastructure can be properly managed and rebuilt at any time. Documentation, books, and websites all contain content that is constantly changing and improving, making them great candidates for version control as well. Again, any content that you want to properly manage and continuously improve should be managed with version control. A distributed version control system is a type of version control system. It usually has these characteristics. Each user has a local copy of the complete history of the project, which is known as a repository. Here we see that there are two users on the team, and each has a copy of a remote repository on their local computer. Even though repositories are distributed among team members, there's also a single remote repository that is designated as the source of truth or official state of the project. This repository is usually hosted in a data center or in the cloud. Another characteristic of distributed version control is that because each user has a local copy of the complete history of the project, they can continue to work while offline. And finally, content is synchronized between repositories by pulling content from or pushing content to a remote repository. Now that we've discussed version control in general, we will discuss Git in particular. Git is a distributed version control system. We've seen that this means that each user has a local copy of the repository and that repositories can easily be synchronized. Git is a free and open source software project, meaning that the code that implements Git is publicly available. No single company owns Git, and anyone can make contributions to improve it. Git has a vibrant community of support and an ecosystem in which many other technologies are integrated with it. Git adapts well to many types of projects and workflows. This means that whatever your project is, or however your team likes to work together, Git can be adapted as a useful tool for your team. Git has been used successfully for very small projects and for very large projects. In fact, software development of the Linux operating system is managed using Git. A Git repository contains a series of snapshots of the project over time, which are known as commits. Each commit contains all of the directories and files of the project at the time the snapshot was taken. You can go back and view the project at earlier points by viewing the older commits. In this example, the repository holds 3 commits. In the first commit, a file named file.txt was added to the repository, beginning the process of tracking this very simple project. In commit 2, a directory or folder named img was added along with an image named image.png. The original file.txt file is also included in commit 2, maintaining a complete snapshot of the project. In commit 3, the file.txt file was modified. You can think of that as version 2 of the file. The project at commit 3 therefore contains a modified file.txt file and the image.png file. Notice that the project has gone through a series of continuous improvements with the help of Git. Now that we have a basic understanding of version control and of Git, let's discuss the options that you have for interfacing with Git, the command line interface and a graphical user interface. In this course, you have a fundamental decision to make. You have the option of going through the hands-on portion of this course using a command line interface, or you can use the free graphical tool called SourceTree, which is a Git client for Windows and the Mac operating system. Let's first discuss the option of using the command line interface for this course and with Git in general. A reason that you should consider using the command line is that command line skills are assumed for most modern developer and IT jobs. The need for these skills is not going away in the foreseeable future. Another reason to use the command line is that if something can be executed at the command line, it can also be automated. One of the fundamental principles of DevOps is to automate everything that can be automated, so using the command line goes hand in hand with automation. Another reason to use the command line is that working with Git using the command line is often fast and easy. Git is designed and documented on the assumption that you will at least occasionally interact with it at the command line. There are some reasons that you might choose to use SourceTree rather than a command line. The biggest reason, for this course at least, is that if you are not already comfortable with using a command line, it can be quite challenging to learn to use the command line and Git at the same time. One option is to go through this course first using the SourceTree client while you develop your basic command line skills. Then you can go through the course again using your newly developed skills. Another reason to consider using a Git client like SourceTree is that some tasks might be easier with a user interface. This is especially true when displaying information visually or when working with interactive Git commands such as interactive rebase. It's helpful to understand the capabilities of the command line as well as the graphical tools in order to choose the best tool for a specific task. Finally, a reason that you should consider using SourceTree rather than a command line is if you will not be using Git often enough to keep your command line skills fresh. It is generally easier to use Git periodically with SourceTree than with the command line, because the user interface guides you through more of the tasks. If you are familiar with the command line, you might consider going through both the command line and SourceTree paths for this course. This will reinforce your Git knowledge and allow you to choose the best tool for a given task. The rest of the course involves hands-on learning with Git. You will see some of the content marked as command line, and some of the content will be marked as SourceTree. It's up to you to decide which path you take. In general, the concepts that you learn are the same for both paths. Here is a brief review of what we've covered. Version control enables teams to manage a collection of files in an agile way. This collection of files is called a project, and Git is flexible enough to manage many types of projects. Git is a distributed version control system. This means that users work with local copies of the repository, enabling them to work while offline and synchronize with other repositories at a later time. A repository contains the project history as commits. A commit is a snapshot of the entire project at a point in time. You have the choice of working with Git using a command line interface and/or using a graphical user interface. At this point in the course, you'll start working hands-on with Git, so select the path that makes sense for you. If you are in doubt, we recommend starting with the SourceTree path.